very important subject, and you definitely need to be proficient with that, because it doesn't matter where you go, you'll be asked questions about it. Okay? So not many, fortunately, but definitely have to be able to answer immediately, okay, without hesitation. Because every hesitation indicates that you are not proficient. Okay? This is that kind of a subject. Okay? So if you work with the SQL, you know SQL, you should be able to answer very quickly and track it. So let's start from the refresh the memory. So I'm not going through the relational database structure and how the building blocks, relational database building blocks. What we're going to do is just refresh that memory that there is a language which allows us to retrieve data, retrieve information from the database, and that language is called SQL or SQL, either way. And the SQL has some statements which allow us to retrieve information, insert information, update, and also administer the databases. So one of the fundamental statements are select statement, which allows us to retrieve information from database. Basically, using select statement, we can fish out information, whatever is stored in a database. But select statement, the way it is written here, like select column names or fields from the database or table name, will retrieve us all records, essentially. Okay? In many cases, we don't need all this huge amount of information to be retrieved. We have to be very selective. We'll have to be very selective and very specific. Okay? For example, if we like to retrieve information about a particular department, a particular pay period, or whatever. So in many cases in real life, we don't use all the information which is stored in a database table. We'll have to be very specific. So we can actually be specific in two ways, because remember, database tables are two-dimensional. So actually we can restrict in both dimensions, in one dimension or another dimension. If we like to restrict on a vertical dimension, with other words, we like to restrict information by fields, what we like to retrieve. We like to retrieve first name, last name, salary, start date, manager ID, whatever. We should specify these restrictions here, field names, okay, separated by comma. When it says column names here, it means fields. First name, last names are separated by comma. If we put star here, it means that everything will be retrieved. Okay? In that case, we will retrieve information by the particular fields we are interested in. Okay? Second restrictions, basically, so second filtering, we can achieve when we restrict specific records, actually restricted horizontally. In that case, you can not simply state it whatever information you need here for. You have to provide logical statements saying where this, and this. Okay, and these statements will be, only records which will match these restrictions will be retrieved. So you have to put logical restrictions, which are called predicates, and in that case you can actually restrict either horizontally or vertically, either way you like. Okay, so we did a couple of we did many examples in the previous class. Like this we selected everything from employees. Star means select all fields and all records. Essentially, we retrieved whole table and we saw the whole table listed. This one, table employees, department and job history, we actually queried these database tables and we retrieved information. In this particular case, we selected specific fields. In this case, we retrieved only first name and last name only. We didn't retrieve salary, manager ID, commission percentage, and start date, whatever. We retrieved only first name and last name from employees. And this first name and last name are fields in this table. Okay? And this table contains more fields, but we specifically retrieved this one. And we retrieved all the records. Especially, what I mean is that if the company has 107 employees, we retrieved first name and last name for all employees. We didn't restrict these employees by we didn't implement any other restrictions. Similarly, in the second case, we say select department ID, department name from departments. Departments may contain more fields than just this listed two. But if we query, if we wrote the query this way, we retrieved all records, but only department ID and department name for all these records. Okay, we didn't retrieve information about location ID or ID or other information. Third is similar. So in this case, we implemented a logical statement which allows us to retrieve specific number of records. Okay, so it means that we look here. So I'm selecting all fields. Basically, I'm retrieving all fields from employees. It means that I'm expecting to see first name, last name, manager ID, all fields. But this employee must satisfy this condition. I'm using this condition, which is logical condition, salary greater than 5,000. This is logical. And the answer to this question comes only in one or two ways. Okay, either yes or no. You don't have third answer. Okay, you don't have maybe or whatever. Okay? So all employees who satisfy this condition will be retrieved. All other employees who do not match salary-wise, so they will not be retrieved. And these logical conditions we specify using keyword where. Okay, this is actually allows us to specify the predicate, and this where allows us to retrieve specific records, not fields but records. Okay. So if we have 107 employees in a table, we may retrieve only maybe say 50% of them, maybe 40%, depending how many employees satisfy this condition. Or if no one gets more than 5,000, then no one will be retrieved, but that's a valid answer. And similarly, we have here the statement, just make sure that this value, which encapsulated in a logical statement, encapsulated in quotes, is case sensitive. So, because that's a value. SQL statement itself is not, but the values which you specify in the logical predicates are. Okay. So, and then we can create as many, we can specify as many predicates as we want. In this case, we specified only one, but there is no restriction to specify more. So we did that. We used the logical operators to do that. And here's an example of two predicates. Okay, there is no limitation how many you can put, but more predicates you put, more difficult it is for human being to comprehend, and more complex it becomes. Okay, so think about that. Explanation of that. So we did this exercise, right? We tried to find out all this, fish out all this information from database, and then we, I believe we did this one, right? Or didn't finish. Correct? So let's try to accomplish this. Okay, maybe try for 10-15 minutes, and then we'll continue. We did this. It means that we had another exercise. Yeah, we have aggregate functions. We did this, and the like operator is null operator, and I believe this one, yeah. Okay, so we have aggregate functions, which is, let's go back, which are these: count, sum, average, maximum, min, which allows us to retrieve summary of the records. Okay, for example, if I create a statement saying, give me a count of employees in this company, I expect only one simple integer answer. So like 107 or 200, and if there is no employees, there will be 0. Also, I can calculate the summary of their salaries. We did that, okay, how much salary they have. So definitely I can retrieve all records, or retrieve all table, and then calculate this value programmatically on my machine. But it's much easier and nicer if we ask the database to do that job for us. Okay, so in that case, we have these functions available. And we used these functions before, so it's time to do this exercise. I believe this, we did half of it, right? So maybe 10-15 minutes we allocate to that, and then at the end we'll go forward. Okay, let's try to accomplish. First question is how many employees work outside of the US? We have to actually think about that statement. So how many employees? It means automatically translates into select count, right? Okay, count starts from employees. Okay, that will tell you number of employees. But if I run it like this, it will give me 107. employees, which is not correct. I have to specify the logical statement which will allow me to retrieve that information. And then if you look at the employees table, you will find out that this information is not there. Basically, location, which is by countries, is located in some other table. Okay, it's not in our employees table.
Yeah.
So it's our task to find it out. So my first idea is just to look for departments or locations table. Okay, so I'm going to say I'm executing this statement. Select start from locations, just to make sure that I'll see what information is stored there. I'm retrieving the table locations, and you see that location is actually the right place to look for. Okay, because location contains information about countries. Okay, so if I restrict the departments or whatever by this country ID, I can get location ID here. Okay, so essentially I'm going to create a table or retrieve the values of location ID by country. Okay, so I have to write this statement. I'm saying select start from location. So actually, to be more exact, I have to say select location ID. ID, because street address, postal code, city is not interesting. I'm interested only in countries. So I'm saying select location ID from locations where country ID is not equal to US. Correct? That's a logical statement. And you see that the country ID comes by a capitalized code of the country, and I have to use exactly as is. So this statement shows me all location IDs, which is not in the US. So if I run this statement, I will get some list. Okay, so 1,000, 1,100, and so on. It means that I can get these location IDs. Okay, but that's still not an answer. Right? So where I can look, turn my attention to find these answers? Probably departments, right? Let's go and see the departments table. I'm saying select star from departments. So if I execute this statement, I will get the following information. You see that I have department ID, department name, manager ID, location ID. So essentially, I have to query 3 tables, and the whole logic will look like this. I have table employees, and employees has whatever data, and one of the field in employees is department ID. Essentially, this field shows which department employee works on. Okay? Now, this department ID is a foreign key here. Its primary key located in departments table, where it has department ID is a primary key. It's a PK here and FK here. Okay? So this is, if you look at the database design, that will be the case. So essentially it means that department ID is a primary key. It appears only once in department, but it may appear in in multiple values here in this field. Because we may have several employees working for a particular department, so department ID may be repeated in this field. So that's why it's called foreign key, but it's a primary key here. Now, also we have locations table. And locations has location ID, which is a primary key here. Okay, it lists the location ID, and another field is country ID, right? ID, which is not the primary or foreign key here. Now, location ID, we have the field in the departments. We have location ID here, right? ID. Location ID here is a foreign key. It's a foreign key here, and it's linked to this primary key here. Okay, that's how the structure of these 3 tables is. Okay, looks like. So what happens here is that the first part of our initial question, we have to query this table, but the last part comes eventually to this table. Okay, but these tables are related to each other. okay, we have a virtual values, okay. So this table has department ID as a foreign key, we have department ID here, and department table is actually kind of a link between employees table and locations table. You feel that, okay? So now we start from the backwards. We start from here, and I already have that statement. I'm saying select all location IDs from locations where country ID is not US. So if I execute this statement, I will get some values, which I'm not interested right now because I know that I can retrieve them at any moment. Okay? Now, next statement, select stuff from departments. I have to say where location ID. ID. Next, this will be in.
Select location ID.
Where location ID. I have to put a logical statement here.
In locations.
In. Now, in this in, I have to specify the list of values, right? But this is list of values coming from this statement. Remember, I didn't write it down separately on a piece of paper because I know that I can recreate it at any time. So if I copy this statement and place here, I will get department IDs which are located outside of the US. No. Because I don't know the range. I don't know the minimum and maximum. I know that it's a list. That's why I say in. And I should not use equal because that will be an error. So in this case, I'm getting departments which are located outside of the US. Okay? I'm combining, what happens here, I was combining these two tables together. Okay? This and this. I'm finding departments which are located outside of the US. Okay. Querying these two tables at the same time. But this is not the end of the story. I have to actually link this one to this one. I have to say select start from employees or count from employees where department ID is in that big list. Okay, because essentially I'm getting these department IDs from here. But I like to get it programmatically rather than writing down 20, 40, 80, and 70. Okay? So I have to modify my statement as well because I'm not interested in all these fields. I'm interested only in department ID. So I'm saying select department ID. ID from departments. And that gives me this list, 20, 40, 80, and 70. Okay? So now I have to go to my first statement, say select count from employees where department ID in. And then I have to paste this statement, this one, into these parentheses. Okay? So if I run that, it will give me 38. Okay? So that's a statement. Okay? It's clear? No? Okay. So, can we move to the next one? Okay? So next question is find out what department employees from outside the US work in. That's not a big deal because we already did that as a part of the first question, right? The first exercise. Next, third one is find out how many employees work in a Bay Area. Okay? So that's a little bit tricky one because we don't have Bay Area in the table. So very dirty and quick solution will be just to base our search by phone numbers. Okay, That's what it is. What we need to do is just say select count. Actually, let me make it separate. Okay. Select count star employees is where phone number what should I put here?
650-408.
Which operator? Equal? No, like. Because like is actually allows us to specify the possibility. Like we have to say 650 star, right? Or so what else we may have? 408. What may have also 510. 510 no, it's big. 415. 650. Well, we said 915. That's pretty much it, right? I don't know the new prefixes, but that's what it is. So if we run this statement, we'll get 0 people. Okay, so it means that we don't have anyone working in Bay Area. Okay, so this is valid answer, but if we include other area codes, we may get some. So this is actually very quick and dirty and not absolutely correct answer. More correct answer will be if we go to department locations, or actually office locations, right? Getting the addresses because location has addresses, right? And then based on that address, we can find out is it in a Bay Area or not. Okay. So in order to do that, we have to go also to the postal office, download the database from there. They have the database, all the postal areas for Bay Area or whatever. They have that. It's freely available in Excel spreadsheet format. We have to download it, put in our database, and we combine these two tables together to get absolute correct answer. Okay? So that's another way of doing it. Okay. But this is very quick. Oh, actually, yeah, that's correct. Statement is correct. Okay. It starts from this area. The phone number should start from this area codes. Okay. So we can have 915 or whatever 925. We can have whatever. What else we have? We can put a couple of other phone numbers and see which we get. Okay. It means that not always the information is in the database in a very accurate form. Sometimes you have to make tricks in order to reach out this data mine, this information.
So like in this case, sometimes people have a different phone numbers, but they're still living in the area.
That's also correct. That's why I'm saying quick and dirty solution. Okay, I didn't say it's accurate. But if you like to have an idea how many people work here, just you may get that. By no means this is the accurate information, absolutely. So to get an accurate, you have to get address and then compare that address with the postal code, and then you get. Actually, you need only postal code, only that piece of information. You don't need even address. Okay. Said that. Find out employees who do not report to the manager. How a statement will look like. You should be able to tell me that. I like to find out person who do not report to manager. And select. I'm not interested in count of these people. I mean, how many? I'm interested in people. I select staff from employees. This where manager ID. Manager ID. Then the logical statement. Which one?
No,
Just now? That will not work.
No.
Is now? Are you sure? So you get one answer, but you get one person who does not report to any manager, who doesn't have manager. This person doesn't have manager. But the question is, still remains, is this correct answer or not? Do we miss something? It's a very difficult question because we don't know how the information is stored in database, right? If HR decided that if manager is not there, okay, if person does not report to manager, then manager ID should be specified as 9999, okay, or -1111, okay. So in that case, we miss these results. Okay, so we have to ask database designers or DBA how they specify a manager which does not exist. Okay, so this is obvious one is null, assuming that field manager ID allows to be nullable. Okay, in some cases it might not be. Okay, so it depends. So we have to look at how the database is designed. Okay, because at the beginning, this is just a guess. This is not absolute correct answer unless we know how the design works, okay, how the database design is. Okay, any questions? In other words, don't run on assumptions when you query production databases. Okay, always ask. Find out who is getting highest commission. So, how many answers should I expect? Why? What by one?
Zero or zero or more.
Well, not one.
It cannot be zero if anyone is, at least one person in the company gets on a commission percentage, you cannot get zero. If everyone works on salary, that's a different story. But we are talking about people who are getting highest commission. What if there are 3 people getting the same commission? Will they retrieve? Absolutely, right? They are getting the highest commission. So it means that you should not limit your answer to 1. Okay, if you get 2 people or 3 people, you should not be surprised. It depends on the money they make. Okay, so the statement will be the following: select, start from employees, where commission, show PCT equals. I have to specify maximum commission from this table. How I do that? I don't know that value, but I should be able to retrieve it. So I have to write another statement here, right? Saying select max, correct?
Yeah.
Commission PCT from employees. It turns out to be John Russell, who's getting 40% commission? Oh, 0.4%, I don't know. I don't know how salespeople are working.
Should 2 bring it at the end?
No, should be 1.
After the last one.
Yes. 1 parenthesis. Yeah, it means that we don't have this area. Yeah, it means that we don't have any employees whose phone numbers that with the 515. Find that employee whose phone number is 515, starts with 515, and then we'll see how this is. What the minimum?
585. Start. Then it says there is no start.
And then the found? Okay, let's see. It's impossible. You don't have 5 on. It's impossible.
5 and 0.
5, sorry? 510? No. Something is wrong here. Either like operator does not work, we have to report to Oracle, or something wrong with our table.
The 6 by 0.
Okay, that's a previous exercise. Excuse me. It doesn't mean I'm working with too many languages in the same day. Okay, it should not be star. Like doesn't operate with the star. It should be percent %. Thank you for correction. That's my mistake. Yeah, I was working with the stars today a lot. So yeah, absolutely. So if we run this, we'll get 45 people. Okay? Sorry, guys. Sorry for the confusion. Yeah. Bash files actually. Change my logic today. Okay? Thank you. So for commission basis, we got this person, Russell, John Russell, but there is no guarantee that it will be one, because if there is another person who's getting the same commission 40%, then you'll get that person as well. Okay, so that's how we retrieve these people. Next question is find out who is employee number 1 hired first. So what's your logic? What's the algorithm of solving it?
Select
ID equal year 1.
Which table we're querying?
employees.
Higher underscore date.
Higher underscore date.
But what happens if that person is not in the company anymore? And still not employee number 1, right? What happens then? Right? So it means that we have to be more critical. We have to be actually thinking broader than one table. It means that that person, if he's hired first, the employee number 1, is not in the company, he's not in the employees table, because employees table lists only current employees. He will be in the job history table. Okay? So what you need to do there, you need to find out a minimum date from job history and compare with the minimum date in the employees table, and find out which is the absolute minimum. Okay? If you find absolute minimum in employees table, then you have to query employees table. If not, you have to go and make a query in job history. Okay? So when you do these two searches, then you'll find out what the absolute minimum date is. And then, based on that value, you have to go and query the appropriate table to retrieve that personal information. Can we do that? Sure. So find out who is employee number 1. Hire date, right? Because that's a field from employees. That date is June 1787. Okay? And then in jobs history, I believe it's called start date, right?
End date.
Start date
Start it.
from job history. So if I run this, I'll get 17th of September 87. It means that we have to query employees table. Make sense? Because September is definitely coming after June. So we have to query the employees table. Select what we're actually selecting from employees. We're selecting star, right? From employees. where start date equals select minimum start date from employees.
Start date is not in input.
Hire date, sorry. Hire date? I believe it's hire date, right?
That they
Yeah, hire
also-
underscore.
Yeah, I believe it's hire date. Yeah, we got Stephen King, one person. Is it possible that two people will be retrieved? Absolutely. Because if two people are had the same day at the company, no problem. That's we'll get to. Okay, the last one is how many people work in each department. It's kind of a difficult to comprehend because so far, which we are all exercises which we are doing, we're doing going actually writing a statement, and that statement we're retrieving values from the database from top row to the end. Okay, and that's how all our statements work so far. But in this case, we'll have to do a little bit different exercise. What I like to do, I like just to create a bucket for each individual department. And then while I'm going from top to the bottom, I have to put appropriate people into appropriate buckets, okay? So at the end of the day, at the end of my search, I actually count the number of these employees in the individual buckets, okay? So, but count the number of buckets, that kind of look like another statement, correct? Because first I just went through, I go through the table, sort people by buckets, okay? That table finishes, right? So in order to do another select statement, I have to do it second time, right? Because first statement is already done. I selected people. Now I have to kind of sort it. So this kind of exercises is done using special statement which is called group by. Group by essentially creates a bucket, and then if you need to do it several times, or actually that's a proper statement. Because select statement goes only through the table only once. It does not go back and does not start again. Either you have to write a PL statement, PL script, which will iterate through the loop, or you have to use bucket using group by. And here is how it looks like. Grouping. So this statement which shown at the bottom, select department ID count, start from employees, group by department ID. Okay. So this statement works in Oracle. That will not work in Microsoft SQL statement, SQL Server, because yeah, it will work. It will work. But if you select something else, it will require that its department ID will be listed here. So basically, Oracle does not have that restriction. Okay. So what the bottom line is, the statement might differ from database to database, and if it's working in Oracle, there is no guarantee that it will do the same in the Microsoft SQL statement. You have to adjust that. So what this does, you'll get table, actual result set, department ID and number of people slash number of people there. If you like to get department name, this might fail. Or if you like to get manager ID here listed, and then number of people in the department, the number of people listed together with him, this will fail because you'll get a special statement saying that group by does not allow to be actually how the statement look like. Let's see. That's 59. That's good. If I execute this, you will get department ID and the number of people working in appropriate department. But if I like say department ID and then say first name, for example, comma department name, department ID, something like this, right? So people, first name of a person and then department ID and number of people in the department. it's not a group by expression. So it means that you cannot mix this first name with the department ID and then if you're grouping by department ID. First name is not relevant. Okay? So you cannot mix that. If you like to get first name and last name of people and the department, you have to modify the statement. Okay? So, but if you see this one, not a group statement, it means that you mixed a field which is included in the group by department with the select one. Okay? So that's how it is. Any questions? No? Okay. So, yeah. So find out who first name, last name gets top salary in each department. For example, a statement like this. So if you write it like that in a group by, simple group by, it will not work. Okay? Because first of all, when we're grouping, we're just going through the table. Okay? Now, in order to get first and last name, we have to actually do it once more, right? Just to find, which a select statement would not allow you to do. Okay? So you have to use special syntax, which is called partition over. Okay? To create multiple buckets. Okay. The next statement in the SQL are insert, delete, and update. And these statements are actually coming after select one by popularity. Okay, together, select, insert, delete, and update contribute maybe say 90-95% of all SQL statement. So insert statement allows us to insert record into a table, and this record will go at the bottom of the table, not in the middle, not at the beginning. It will go to the bottom. Now, statement looks like this: insert into. This is how the syntax is, and then we specify table. And then we specify this, use this keyword values. Okay, so the statement will be like this: insert into employees values, and then we list values, and these values will go into appropriate fields. For example, if I write it like this, insert 207 will be employee ID, test his first name, test and last name, TT test for his email address, this is phone number, start date, department ID, salary, the commission percentage, employee manager ID, and 60 is, what is 60?
Department.
Department ID? Oh, this is the job ID. Okay, so IT programming is job ID, and 60 is department ID. Okay, in that order. So basically, I list the values in the order fields are located in the table. Okay. But you realize that this is a little bit difficult to do, because every time you have to look at the table and you have to look at the value here of numbering. So there is a solution for that. This is a short form. You can specify after employees here. Let's do that. I'll show you. This is for space reason. I wrote the short form of it. 61. So I'm taking this statement. So I'm writing this way. Say insert the employees. I'm saying employee ID, comma, first name, comma, last name, and so on. And then I say values. So essentially, you see that I'm inserting okay. Here's my statement, how it looks like. I'm saying insert into employees. That will be, first will be employee ID, and that will be 207. So after, which is coming after values, 207. Test will be first name, last is a tester, and so on. So essentially, I have a possibility to list field names in the insert statement, which makes life much easier. I don't need to go to the database all the time and look at the field names. Field names can be specified here, just basically listed. Okay.
So we have to write it vertically?
Typically, the developers, they write in a column, okay, because that's easier to see. okay, instead of the horizontal that arranged vertically, so that's much easier. See, and then tester will be TT tester, and this is the phone number, and then the fields will be listed here.
So after employee ID, period? Or
Yeah, it should be comma.
Comma.
It should be comma. Comma. Yeah.
Is
And so-
sequence essential?
Sorry.
Sequence essential?
Yes, sequence of the values is essential because the values matching exact field sequence of fields. Okay, so that's why I list fields here. For example, first field is employee ID, and then first name, last name, and then I specify values accordingly. I didn't finish this because I have to list all of fields here, but just for time and space reasons, we don't do that. But that's what should be done, because you cannot specify that this value, for example, 207 goes to the employee table specifically, and specify the last, for example, instead of first. Okay, you cannot do that. Okay, you can do that when you insert values using stored procedures and stored procedures. So essentially, what happens is that at the database level, you can define a function. And then saying, you know what, we call this function and provide all these values to the function, okay? And then this function will go and insert for ourselves, okay, this value. This is actually a preferential way of doing it instead of immediately inserting values in the database for several reasons. First reason is that we can perform a check, okay? For example, we can verify that the first name coming in a capitalized form, in a title case, okay? Or first name is provided and it does not contain numbers and so on. We can do all this verification, and that function can do this verification, and if the verification passes, then it can go and insert it. Okay? And it also is very proof against the different kind of hacker attacks, because we can implement a lot of verification, and if something goes wrong, it can report back something is wrong, whatever. Where Oracle might not be a direct report. Okay? So you may not get that information directly. Plus, you can compile this stored procedures so they will work faster. Okay? Much faster than you individually execute insert statement. Okay? There are several other reasons why we use stored procedures, but that's what it is. So in a company, when you do something, you typically do with a stored procedure. You can create stored procedures and do that. It's actually listed in a book if you're interested in it. Okay. Anyway, any questions? Okay, let's go back to the presentation. So in this particular case, we inserted a new employee tester, and then if auto commit, we have observed that small checkbox in the upper left corner, which is called auto commit, and by default is checked. We have to uncheck it and don't execute this statement. So we're going to see cover auto commit and commit what it is a little bit later after the break. But right now, let's focus on the insert statement. So insert statement written in this way is a little bit dangerous because I hard-coded the value of the employee ID, like 207. Okay. In this case, I have to guarantee, I have to make sure that 207 is free, is not used, because if it turns out that there is already existing an employee, the employee exists with 207 employee ID, this statement will fail. Insert statement will be thrown back by Oracle saying, you know what, you are violating primary key constraint. Okay, you cannot have two employees with the same employee ID. Okay, you actually compromise the whole database ID of this table. So that's why it's my job to make sure that this 207 is unique. Okay, but you realize if I'm inserting an employee and I'm working for a big company, that might be a tedious task, right? Because people may make mistakes, forget, whatever. And then we actually, if we don't provide this correctly, then that employee will not be hired, right? That will be completely HR fault. So there is a way to do it automatically. So in this case, instead of hard-coded value 207, what I do, I substitute with the select statement. In this case, I'm selecting the maximal employee ID from the table and adding 1 to it. Okay? So in that case, I always I have a guarantee that every new employee which I'm inserting will have a next available number inserted for this employee ID. Okay, that's one way of doing it. This is not a nice way, by the way. There's another way is to create a sequencer. Okay, sequencer in Oracle is a special function which you can create yourself. which is essentially nothing but a generator of numbers. Okay, you can create your own sequencer and then say, you know what, it should start from, for example, 1,000 and give me next available integer. Okay, basically increment by 1. Every time you call that sequencer, it will give you that number, the new number back. Okay, so instead of calling this select long statement, I can call my sequencer, and that will be okay. Basically number generator. You can specify all other conditions, whatever you like. It is possible. That's how it is done in Oracle. Okay. Any question? So clear. Okay. So next statement is delete statement, which, as you may assume, deletes a record from the database. And here is the delete statement in action. It says delete from employees. This is very dangerous if executed this way because it will delete all employees, okay, from the table. Depending on the situation, depending on the condition, that might be reversible, might be irreversible, okay, depending. But bottom line is, you should never execute statement like this. It should basically, this is only for illustration purposes. Never. In other situation, you should not do this, unless you specify with a predicate, a logical statement. Okay. And this logical statement might be specified like this. For example, delete from employees where employee ID is 207. Okay? In that case, only one employee ID will be deleted if that employee exists. Or you can also specify the same statement like this: delete from employees where email equals TP tester. So which way is more preferable? Which syntax is more preferable? First one or second one? Second? First one, because the second one does not guarantee that you have unique correlation between the emails and the employees. I've seen example, real life example, when two different employees have the same email address in a database. Okay, a real example. Some was not. I mean, I don't know how they didn't, how they shared email or how the actual email server figured it out. But indeed, they had this one email for two different people. So in that case, you have to rely on employee ID. Okay, employee ID guarantees you that there will be only one person, 1 person matching that employee ID. So the delete statement is actually better written to first one using employee ID. Plus, you can also automate this task in Oracle. Just, for example, when you delete an employee, you can modify the way that some other actions will take place. For example, next action, when you're deleting someone from employee, that employee information should go into the job history table, right, automatically. That's not actually luxury or just the will of the company. This is actually a business requirement. Okay, business rules require that you keep employee records for 7 years. Some companies keep it forever. So in that case, it will be definitely much better to automate this process. So as soon as you delete employee from the employee table, this record automatically goes to the job history table. Okay. You can specify the range in predicate. You can say delete from employees where employee ID between 107 and 127. In this case, 21 employees will be way up from the company. And also, you can automate this process by sending email to the EDD. You can send email to the investors, whatever. Okay, so all processes which can be done can be automated. Okay. Next.
Specify one or more conditions.
This is not multiple conditions. This is done using triggers. Essentially,
No, like just employee ID. Say we want to combine two, like where specifically employee ID and say department ID. We just want to delete that. We can combine that. We can use that.
yes, you can specify any other conditions, logical conditions here. No problem. Absolutely. Or, for example, you can say delete employees between this range, but who started in the last year, for example. Okay. In that case, only employees who has employment history at that company less than a year, then they will be actually. Okay, so conditions might be complex, might be simple as this. Okay, so you have free of doing that, pretty much like you do with the select statement. Next command, which is not on the title, is a truncate command, which essentially deletes the table irreversibly in any cases. Remember, when I was saying delete command, I'm saying you have a possibility, provided some conditions are met, you have the possibility to revert it. Okay, basically, delete might be reversible, might be. Okay, not always, but might be. We'll cover that. But the truncate command is actually irreversible. What it does, it goes and erases all table data irreversibly. Okay, so why we have two different commands? Because they have differently, they operate differently. When you execute this command, essentially, even if you don't specify the predicate, doesn't matter. Delete command goes and operates record by record. Okay, so as such, it's slow. So if you're deleting 1 million records, it means that you are essentially asking the database to perform 1 million operations, one record by record. Okay, and even if you specify the predicate, it still goes through from top of the table to the bottom, checking the conditions. So it will be slower, but anyway, it goes record by record. When we say truncate, it's kind of a sweeping, eraser, big eraser, which goes and deletes table as is, as a data. Okay, pretty much like you deleted a file on your computer. Okay, without looking it, without reading that file, simply putting it in the trash can. Okay, that's why it works faster, much faster, because it does not care about records, it does not care about fields, whatever. It just basically swaps wipes out. And this is not reversible. So essentially, if you execute truncate command and you regret it about it, so that's too late. Okay. Bottom line is, every time you execute delete, truncate, basically delete commands, make a backup. Okay. It would not hurt. The disk space is cheap nowadays. Okay. Make a backup before doing this command. Otherwise, you might be sorry. Okay. I heard a couple of stories in my life. People were laid off or actually fired because executing this truncate command on the wrong place, wrong time. Okay, and it took a while to restore the database. Okay, personally, I don't like this. Okay, but if I work on a big database and I need to clean it, that's the truncate command. Okay, so I don't have choice. Update statement does not create new records, but basically it updates some values in the fields. Okay, so syntax of that command is this command is following: update, you specify table name, and then you have keyword set, and here you specify field name and the new value which you are going to insert. Okay, for example, if we change the salary, for example, a person gets promotion, then we have to update the salary field, right? In that case, we're saying update employees, set salary, say to a bigger value. This is will be new value, and then you specify the predicate. Okay, you don't like to increase salary for all employees. Here is an example: update employees, set salary 20,000, where employee ID 106. So basically, employee 106 gets 20,000 salary, new value. Okay. And the old value is erased. Old value may be bigger and smaller, doesn't matter, but this is the new value, and that employee is going to get that value from now on. Okay, that's how it works. Any questions? Okay, so this statement might be executed at the company after the IPO. Okay, president may raise his salary to $1 million. Okay, which is not bad. And then also you can update several columns at once. You can set, for example, salary 1 million and then also comma the job title to general whatever CEO or whatever, doesn't matter, or board of directors and whatever. Okay, so it means that you can update several fields at the same time with the same statement. You don't need to run it several times for several persons. So next question is, don't execute this statement. Simply have to write it, but please don't execute, because a lot of people actually did that before. They screwed up the database. So typical example, we have Dana Loretz, employee at the company, And she got married and she decided to change her last name. Okay, it's a typical story, right? And her first name is, her last name now should be Götz instead of Lawrence. Okay, so you have to write that statement which will make the change in the database. Okay, but please don't execute it. Okay, so command should look like this. First of all, we have to find out Diana Lawrence employee ID. That's not a question in the real life because when she goes to the human resources and asks for that operation to be performed, she presents her ID. Okay, so for that reason, I have to say update employees set. Please don't execute this command. Set last name to Götz. Comma, email, Götz, right? Make sense? Because email should be also changed, don't forget about that. Where employee ID equals, for example, 107. Just for example, okay?
This is 107.
Okay, that was not 107, okay. So that's how the statement should look like. Besides changing the last name, email also should be changed, okay?
But sometimes they keep the same email.
I don't think that person would like it, okay? The question here is the following, that email Götz might be already present in a database, okay? So because maybe we have, for example, Dennis Götz may have the same email address, right? So we have to first make sure that Götz is not taken already. So after that, we have to execute this statement. So basically, it's not a simple process, okay? So it may take some thinking, but that's the way you should do it. Otherwise, you'll have multiple emails. Yeah, email is not a primary key in a table. So we may have several same email addresses in a database, and the database will allow that. That's a bad design, but that's what it may happen, okay? In order to prevent that, we have to introduce additional constraints. We have to probably make the email address as a primary key as well, not second primary key, right? Or introduce another constraint. It is possible, but that's the way we go. Okay? So if you are going to test the databases, you have to test that conditions as well. For example, if you are an engineer and you are testing the databases, you might find yourself in that situation. You go to the company, they open completely new project from scratch, and they started to design tables. Definitely, it will be numerous meetings, group meetings, program manager meetings, whatever. You'll get bored of this meeting out of these meetings. But you should always raise the question: for yourself first, how I'm going to test this? Why this is value unique or not? Is email unique or not? Okay, so it will make your testing easier, much easier. Okay.
So putting two conditions is like if say there are two Diana Lawrence in that company.
Yes.
There are two Diana Lawrence. It's good to match two conditions and
To Diana Götz Lawrence would not work because we specify employee ID. Okay, so it means in real life you have to actually. What happens is that human resource clerk may have the following application: providing employee ID. For example, employee comes and presents ID. She types the employee ID punch into the application, and the application shows the photo. Okay, and then they can actually visually verify that that's the employee. So if we specify employee ID, there is absolutely no possibility to change values for another Diana Lawrence. Okay, so we are guaranteed that case.
Why are we updating email if there is confirmed like because of the employee ID is one because we already mentioned
Yes,
that.
because her email address was D. Lawrence, right? We're changing D. Lawrence to D.
We want to
Gertz.
just change it.
Just changing? But this email address may be already present in the database, right? If we have Daniel Gertz, for example, Daniel Gertz may have this email address already. So we have to make sure that this is not taken. In that case, we may say instead of D. Gertz, we say Dan Gertz is abbreviated, Dan something like that. Okay? Email addresses allows, I think, 20 characters, right? Long in this database. I believe it's 20 characters long. So we have pretty much big room for these manipulations. Okay? Okay? Okay, let's go back to the presentation. Here's the answer, and then all these considerations which we already talked about these email addresses. Okay? Email and name should be taken into consideration. So it means that even simple change of the name might produce some, may contain some defects of that statement. Okay, we have to be very careful about that and test that. So next we are going to talk about joins, because that's if you go to the interview on the company, and then your first question on the interview might be, do you know the SQL? And they say, yes, I know. I say, okay, we have a table, employee ID, and employee first name and last name. That's a typical question. And then they say, you know, if I give you employee ID, can you tell me employee first name and last name? Okay? So basically they test your ability to write a basic SQL statement with a predicate. Okay? If you answer that question, maybe another one, which allows you to, where you have to show how you can retrieve information from two tables, like we did department IDs outside of the US, okay? But the third question is, unavoidably, will be joins, okay? They say, okay, can you write joins? You say, yes, I can. And then you should be able to demonstrate that writing joins, okay? So let's have a break, and then we'll continue that with fresh energy, okay? Okay, guys, let's continue. This is a very interesting subject. And you cannot avoid interview questions without being asked about joins. Okay? So, people who have been on interview will confirm that. So, what the join is? So, join is essentially operation which allow you to query several tables at the same time with the same statement. Okay? Essentially, you merge all these tables and then query as it's one, as it is one table. So let's see how we can do that. First of all, when we combine two more tables together, there is a potential problem that field names may collide. Right? For example, if we look at the employees table, we'll see that we have department ID in the field in that table employees, right? And also we have department ID field in a departments table. Okay. So if I join these tables together, then there will be completely unclear. There will be mess. Which department ID we are querying from which table? Okay. So for that reason, we have to be able to uniquely identify fields, so there will be no controversy. So far, we didn't do that because we're querying one table at a time, and there was absolutely no controversy because each within the same table, field name is unique. We cannot have two fields with the same name. So in that case, we didn't care because we know that the field names will be unique. As soon as we move to several tables, we cannot afford that luxury. Okay. Just before we continue, can you start filling? I didn't get this tennis list, but try to put your name and take one. So let's see how we can resolve this problem. First of all, in order to make this happen, we have to use full qualification of the field. For example, when I'm saying select first name from employees, I'm saying select first name from employees. Right? In this case, there was absolutely no doubt that the first name is unique. Okay? But when we make several tables, for example, job history, whatever table, we cannot guarantee that. For that reason, we have to use so-called fully qualified names. Instead of saying first name, I have to use this name, employees. Dot first name. In that case, there will be absolutely no doubt here. Okay? There will be absolutely no doubt that we are talking about first name from employees table. Okay? We can also mix, mix tables from different databases. Okay? So in that case, we can prepare the database, for example, HR.employees.first name, where HR will be database. This is the table name, this is the field in that table. So that will be absolutely fully qualified name for that field. Okay? And then you can query several databases at the same time, mixing tables together, and that will be absolutely no controversy. Okay? So let's look at the example, how it is done. For example, in our first example with the phone numbers and people, we can mix these tables together, and phone number should not be here. Remember that. And then we mix these tables together into one table, and querying one table is always easy, right? If we actually join this table with this one, we can always figure out whose phone number and whose this one particular phone number belongs to. So another example might be like, we like to get a company phone book, create a phone book, but we cannot simply query employees table, because if we query employees table, we'll get first name, last name, and department ID. That I don't like to do that. I like to have a phone book which will contain first name, last name, and department name, for example, marketing, HR, whatever. Essentially, what I'm saying is that this is the information from the employees table, first and last name, but I don't like to put a department ID in a phone book. I like to make it full. But this information is stored in a departments table, and I don't like these numbers. I like only these names. Okay. So in that case, I like to create a phone book which will look like this. It turns out administration role, but these people working for administration. Okay. So I like to create a phone book like that. Okay. For example, first name, last name, and department name. Okay. Department name, not ID, but the name. Okay. In order to do that, I have to go and combine departments with the employees table. Employees table, just put in one pie, and then taking clearing that joint table. Okay, that's the idea. So here's the statement which I like to do. It's just I'm saying select employees dot first name, because that should be unique, right? Unique identified. Employees dot last name, employees dot phone number, and departments dot department name. See, these all are fully qualified names, and I have specified from, and here I list several tables. In this case, I list 2 tables. So far, all select statements which we did had only one table name. In this case, we have 2. Okay, but if we mix these 2 tables together, like in this statement, we have to be very specific and use fully qualified names. Okay, make sense? So in Oracle, you just simply prevent that. If you work with Microsoft SQL Server, you have to calculate them in square brackets. Okay, this is basically syntax differences, but the idea is the same. So let's execute this statement, and this statement I expect to show me employee first name, last name, phone number, and then department name. And how many records should I expect? No, how many records should I expect to get?
All the records.
How many? How many employees we had in the table? Forgot already? 107.
One. All the one.
We are selecting everyone, right? I didn't put predicates here.
All 107.
Yeah, all employees.
You said one. Rows, no? Records. Yeah, how many rows? How many vectors? 107.
Matches only. Like for example, one person matches one working for one department, and only these records will be retrieved. But that's our assumption, and database thinks a little bit differently. So for database point of view, we have two tables here, which we listed, which is employees table, right? Employees tables, and we have departments table. When we combine these two tables together and make a query, then what Oracle does is actually, not only Oracle, but the database does, it actually looks at the entries in the employees table and looks at the entries in the department table. And what happens here is that it takes one record from here, like for example, first person, and then it matches all departments for that person. Okay? So, and then after this is done, it goes to the second person and does exactly the same. So our final result looks like each individual employee working at all departments at the same time. Okay? So which is not the case. So what we actually got, we got a multiplication here. We got number of records from this table multiplied by number of records in this table. So we have 107 employees here, and we have 28 departments here. So we got this 2,900 total records. Okay. So that's what the database did, and that's how we performed the job. Okay. So the result is the multiplication, and that's called Cartesian result. Okay. Simple multiplication of two tables. Cartesian result. Now that's not what we wanted, and we like to specify that condition. We like to say, you know what, database, this is wrong. Basically, physically, one person cannot work for more than one department. Okay, he can be split between two departments, but he cannot work at the same time for all departments. Okay, we don't have these genius people. Okay, yet. So that's why we can say that. Remember that employees table has a field which is called department ID. Okay, and each individual person except one they have a department ID specified. Okay. We like to link this department ID with this department ID. And I say, please retrieve only values where these two department ID coincide. Okay? We haven't done that. That's why we got multiplication. We say, for example, retrieve the first employee, get this department ID, come to this table, retrieve this department name based on ID, and retrieve only that one, and ignore the rest. Okay? That's how it happens in reality, right? One person and one department per person. So we have to update this statement accordingly.